Hey everyone, welcome back to the channel. I'm Nehemiah. In this video, I'm going to teach you protocols in system design. This video is also the second video in a playlist where I'm teaching you everything about system design, from the fundamentals to advanced topics and designing real-world applications. If you're interested, please check the link in the description to watch the first video before you start on this. Today, I'm going to focus on protocols in system design, and the first one will be the TCP protocol. TCP is simply an abbreviation for the Transmission Control Protocol, and it has a number of things I want to talk about. But before that, what is a protocol? A protocol is simply a set of rules that define how components in a system communicate and exchange information. And one of those is called the TCP. So TCP is known as a connection-oriented protocol. So I'll type that, connection-oriented. Can I type connection correctly? Connection-oriented protocol. What does being connection-oriented mean? It means that in TCP, when transmission is going to happen, a connection is first of all established and is confirmed between the sender and the receiver of a message. Messages are only sent, or data packets are only sent when a connection has been established. This is the first key thing that you have to understand about TCP. You know that in networking, messages are broken down into small chunks. These small chunks are called packets. No packet is sent until a secure connection has been established and has been confirmed. And TCP, because of this, is known for something called data integrity. Why data integrity? Because in TCP, in the event that you start sending data to your receiver, the data is sent in a particular order, and that order is actually preserved. TCP ensures that data is sent and preserved in the exact order. In the event that maybe something happened and maybe data is corrupted or an error happened, TCP is known for doing retransmissions. So a retry is done for all packets which were lost, all packets which have maybe errors that were corrupted. Something is redone, okay, or retransmission happens so that the receiver gets data as expected. And because of this, TCP is a very reliable protocol. Have that in the back of your mind. That number one, it's connection oriented, meaning that data is transmitted to the destination only after a connection has been established and confirmed. And also that the data order in which it is sent to the receiver is maintained. And in the event that an error occurs, then a retry is done to ensure that the data is sent as intended. And of course, all these make it reliable. Then the other one I want to talk about is the UDP. UDP is also an abbreviation for User Datagram Protocol. And let me just type it out. I'll drag this up. Say UDP, User Datagram Protocol. Now, this one also is important, but the difference is that the User Datagram Protocol is not connection oriented. It is connectionless. By now, you're already seeing a disadvantage with the UDP. When data is going to be sent between a send and receiver with UDP, a connection is not confirmed yet. Data is just sent. And in UDP, there's no data integrity. Okay. Why? Because in the event that maybe some packets were lost, there's no retry. Okay. There's no retry. You can't rely on it as much. But because of all this, it is actually faster. Remember, in TCP, number one, you need to establish a connection. Okay, after establishing a connection, you need to make sure that all packets were sent in the same order. After that, you have to make sure that in the event that data was lost, you retry or you retransmit it. Okay, all this takes time. Because UDP does not have this, it is faster, and it is used in things like live streaming, gaming. Okay, very, very important. When you have an application like a banking application, you won't risk using the user datagram protocol. It will hurt you so much. So things like TCP work in banking applications or in applications whereby data integrity is very, very important. So choose TCP when you need data integrity. Choose UDP when speed is way more important than data integrity, like in a live online gaming application. So let's go to the next section where we're going to discuss HTTP, which is the backbone of the web. Welcome to this section. I hope you're not tired because we have a lot to do in this playlist. Anyway, let's discuss HTTP, which is the backbone of the web. It's a very important protocol, and it's also an abbreviation which stands for Hypertext Transfer Protocol. So we're going to discuss it. And like I said, it's the foundation of the modern web. You can't talk about the modern web today without HTTP. It's the protocol that runs all the websites or web pages that you interact with. And it mainly deals with HTTP requests and HTTP responses. The browser you're looking at right now in this video has an HTTP response, and it was as a result of an HTTP request. Just know that as long as you're dealing with the web or your web browser, you're dealing with HTTP. Simply a protocol that deals with how web pages interact or send requests and receive responses. And like I said, it's all about HTTP requests and HTTP responses. So let's talk about one by one at a time. And using that, we're going to go deeper into understanding the HTTP protocol. So first things first, we need to talk about the HTTP request. So what does it entail? The HTTP request is composed of a number of things. The first thing is that it has, remember again, take note that all this is all about the client server model or the request response cycle. The first thing that you have to understand, or the first component you have to know, is that it has what is called a URL. A URL simply is a link that gives us access to a particular resource on the web. Then another thing we need to know is the method. So the number of methods in HTTP, and the method simply defines the action that you want to do. And I'm going to talk about each of these actions that you can do or methods that you can perform using HTTP when creating an HTTP request. So let's go over one by one. So the first action or method is called the get method. I'll put this in uppercase. So get is used when you want to retrieve a resource. So use the get method or action when you want to retrieve data from a resource. Then we have what is called the post method. This one is used for creating resources or creating a resource. So get is retrieve a resource. Post, so I'll drag this up here so you can see it easily. So get, retrieve a resource. Post, create a resource. Then we have put, is for updating a resource. Then we have what is called the delete, and I'm sure you know what this is. It's for removing or deleting a resource. Then we have another method or action, which could be called patch, not could be, but is called patch, and it's for partially updating a resource. So with this, I'm sure you can now know what actions you need to perform when sending an HTTP request. So you have to specify all these actions. Do you want to get? Do you want to do a post? Do you want to do a put? Do you want to do a delete? Do you want to do a patch? Very important. Then something else that you need to understand is what is called the body. Okay. An HTTP, sorry, I need to undo the color. I can leave it in this pinkish color. So the other component of an HTTP request is called the body. So I need to pick the pen and add it here. So we have, after the method, we have what is called the body or the request body. So if someone says request body or body, they are referring to the same thing. A request body is simply data that you send when you're creating a resource. For example, in a post request. Even in a patch and put, you can add data that you want to be used when updating a particular resource. Something else I need to talk about as a component is the header or headers. So I'll just simply branch out from here and say another component of a request is a header. What is a header? A header simply represents metadata, and metadata is data about data. For example, we can have data about our request that tells the person going to process our request that the browser we are using is Chrome. Okay. And maybe the version of maybe the URL or the resource that we want is version 2. So the version and the browser we are using is metadata, and that metadata can be placed in the header section of an HTTP request. Now, let's go one more step and discuss HTTP responses. If you have any question, please leave it in the comment section. So I'll just duplicate this and scroll the bottom and type, not even type, but edit this to HTTP response. So what makes up an HTTP response? It is made up of, number one, what is called the status code. Okay, the status code. This status code helps us to understand quickly what went on from the end of the HTTP server, and is our request successfully being processed or not. And the number of status codes, and they are in ranges. I'll start with one in the range of 200. Okay, there are codes in the range of 200, and these codes simply deal with the successful processing of your HTTP request. An example can be a 200 OK status code, which says everything went on well. Here is your response. When you send a post request and you have created a new resource, you can have a 201, which is a status code that is returned when a resource has been successfully created. These are not the only status codes, they are way more. With a quick Google search, you can find out what the status codes for success in a range of 200 are. The other range is 300, and these are used for redirections to indicate what happened with the redirection. An example is like the 301 status code for a permanent redirection. Then we have status codes in the range of 400. Okay, this happens when the client has an error. Okay, when the client has done something wrong. For example, when they send a request body with invalid data, you can return a code of 400, meaning you have given us a bad request. or you can send a code of 401 telling them that they are unauthenticated or they're not authorized. Then also we have codes in the range of 500, and these codes in the range of 500 are simply to tell the client that something went wrong with the server. So these are server errors. With a quick Google search, you can find out all the codes, but it's not mandatory for you to cram all of them. As you develop and keep growing in system design and building applications, you'll actually train yourself to remember many of them offhand. Then another one I had forgotten is the codes in the range of 100. Okay, these are informational codes, simply to tell us that maybe something is continuing or progressing. All right, this is the first bit of an HTTP response. We have the status code. A response can also have headers, which is simply metadata, like I mentioned when explaining the HTTP request headers. So the same headers in an HTTP request can be the headers in an HTTP response. An example of a header in an HTTP response could be the server which replied to you. And also it could be the type of data that you have received. Something else a response can have is a body. So I'll create my little box and say body. An HTTP response can have a body or a response body. And this body simply can have data that is required by a client and has been provided by the HTTP server. One key thing I need to talk about HTTP is that HTTP is known as being stateless. I'll drag this. In the previous video, I explained the difference between stateless and stateful. If you want to understand that deeply, please watch the previous video in the playlist. It has chapters that can direct you to exactly that section. So HTTP, like I've said, is known as a stateless protocol. It is stateless because every request is independent, and since these requests are independent, you are supposed, or the client that is making the HTTP request is supposed to include all the information necessary for that request to be processed. The server does not memorize or keep or know anything about your request. So for every request, you are supposed to send all the data. But there are ways you can handle state in HTTP, even if it is stateless, using mechanisms like cookies. Okay. In a future video, I'm going to talk about cookies in detail, but think about a cookie as a small piece of data that is stored on the browser and is sent from the server. You can handle state using cookies. You can use things called tokens. I'll talk about tokens in a future video in this playlist. Okay. For now, I just know a token as a piece of hashed data. Okay. That is not easily understood by the naked eye by just reading it, but is shared from the server to the client and from the client to the server or HTTP server. So we shall talk about this in detail soon. Then another thing I need to share with you about HTTP is that HTTP has something called HTTPS. Okay, so HTTP but with an S at the end. This S stands for secure. Okay, and it simply means that the request has been encrypted with an SSL certificate. And for the server to understand this, it must be decrypted using a process called SSL termination. So when you see S, it simply means it is secured and the communication has been encrypted, which is something very, very good. The internet communicates on particular points of interaction. These points of interaction can be called or are called ports. And in a future video, I'll discuss ports in detail. But for now, know that HTTP operates on port 80. HTTP operates on port 80. And HTTPS operates on port 443. If there's anything you should cram about HTTP, is the ports. Cram this for now. It's not a lot to cram. I'm asking you to cram only this. Maybe I will not ask you to cram anything else in this series. Okay? If I do, please hold me accountable. Anyway, let's now move on to another interesting topic or protocol. I hope you're enjoying this series. And again, this is a foundation. Very soon, we're going to go deep, and the foundation always matters. See you in the next section. Hey everyone, welcome to this section. We're going to talk about REST and RESTfulness. REST is actually a very simple abbreviation which stands for representational state transfer. For something to be called REST, it must adhere to a number of principles. And I'm going to share those principles right now. You may be wondering, what is REST? If someone asks you what REST is, tell them it is an architecture style which is based on HTTP. If you don't know HTTP, you will struggle to explain. To understand REST, you need to understand HTTP, because REST is based on HTTP. So for anything to be REST or RESTful, I need to explain some of the principles and the best practices. So let's talk about this briefly, because it is something important and it's based on HTTP, which is the protocol I explained in the previous video, rather previous section of this video. Because when I say video, it may mislead you and think it's a different video, and yet I'm referring to a section in this same video. So let's talk about them. What makes something REST or RESTful? I will copy what is up here, duplicate it, and type one at a time. So the first one is that it has to follow the client-server architecture. Whatever you're implementing must follow the client-server architecture. REST loves separation of concerns. The client, what you can think of as the front end, should be separated from the server, what you can think about as the back end, so that you can grow, maintain, and scale the client separately, grow, maintain, and scale the server separately. Then another thing is that it should implement statelessness. Like I told you, REST is built on top of HTTP, and we talked about this in the previous section and in a video, which is the first video in this playlist, where I emphasized statelessness and statefulness. Now, I'll touch on it again. Statelessness simply means that the server does not store any session data and has no memory of any session that a client is having at a particular moment. Every request must include all the information that is enough for that request to be executed successfully. So every interaction between the client and server is stateless. And this is very good because it helps us in creating distributed systems. In a distributed system, if you have to store sessions for every interaction, then you may have to struggle with a big challenge. But statelessness is something that makes distributed systems very easy or easier to implement. The next one is that we have what they call layered system. With REST, you can have layers. For example, you can have your database access layer, then you can have your security layer, you can have your business logic layer, you can have your caching layer. And that brings us to the next principle, which is cacheability. I hope I can spell it correctly. So cacheability simply means that resources which are frequently accessed can be stored temporarily in memory and not disk, so that when they are required, we reduce the load on the server having to make database access, and you only access this from memory, which is faster. Then another point is that we need to have a uniform interface. A uniform interface. What does this mean? REST says we need to have access in a standard manner. We need to have access to our resources in a standard manner, which should be consistent. And I'm going to talk about some of the things that can help you have a consistent way of access. Next is that everything is thought of as a resource. For example, if you have an e-commerce system, you'd think about resources as users, orders, cart items, products, categories. Everything is thought of as a resource. Now, how can you have a uniform interface? It's by implementing some of the best practices. For example, when you're naming your URLs, you have to be consistent. There's need for consistency in URL naming. What can you do to name your URLs consistently? One thing you can do is to use plurals. Okay, use plurals, and they have to be plurals for nouns. Let me write this again to make it better. So they have to be plurals and they have to be nouns. Don't use action words or verbs. For example, it's best to have an endpoint or URL that is /users. Having it as, for example, /user is against the REST principle, or something like /add. Okay, add is an action. Add user is also against the REST principle. So make sure you use plurals, and they should be nouns, not verbs, not action words. All right, I hope you've understood that. Now, something else that you can use as a best practice is to use proper status codes. In the previous section, I talked about status codes in detail. If you missed it, please have a look at it. So I'll copy this and drag down and say we need use the proper status codes. If, for example, you have deleted something, do not return a 404 status code. If something has been created, do not return a 500, return a 201. So always use proper status codes. Then another thing you can do is to use versioning. Why? Because versioning helps people who have been using an old interface from not having breaking changes, but continuing to access what they have been using. And those who are using something which is new to continue enjoying that new resource that you have created. Otherwise, if you don't version, then people who are using the old thing will complain. Okay, and you may actually lose business, or you may cause a disruption in the clients. So always version things. So this is version 1, this is version 2, this is version 3. So that's your clients who need version 1 continue using version 1, and those who need the latest version can continue using it. Another one is pagination. On this channel, I have a playlist where I build a flight booking engine, and it covers almost 98% of all these concepts, including pagination. Pagination simply refers to breaking out your data into chunks. Instead of giving all the data to your client, you divide it into chunks and give it to them one piece at a time as they request for those pieces. And it's one way to avoid overwhelming a client. What else comes to my mind? Implementing authentication is a very good practice. Why? Because authentication is how you know who a user is, and can lead to another step called authorization, where you determine what a user can do in a system. So if I've missed out on any, leave a comment and I should be able to look at it and be happy that you've shared with us some valuable knowledge. In the next section, I want us to discuss real-time communication protocols. See you over there. One thing I forgot to talk about was RESTfulness. An API is said to be RESTful when it implements all the principles that I've talked about. Something can be only REST if it implements any or some of these principles. So with REST, you don't have to implement all, but RESTful simply implies you follow all the principles and best practices. Hey everyone, welcome to this section where we're going to talk about the real-time protocols. There are a number of them, but we're going to talk about one at a time. The first, I need the box to write in. So I'll just copy this shorter one, duplicate it and drag it down here. So the number of protocols, let me change the color. So the first one, if you talk about is polling, then I'll touch on WebSockets, and then long polling, and then server sent events. I think this will be basic enough for this video. In case of anything that is complex, please let me know in the comment section. And of course, going forward, like I told you, we shall keep going deeper and deeper while we combine everything in this playlist. All right, now, what is polling? What is a WebSocket? What is long polling? What is a server sent event? This should be server, not whatever I had typed. Okay, sorry about that. Now, let's talk about one by one. But even before that, we need to define real-time communication. What does it mean to have real-time communication? It is simply a continuous exchange of messages between a server and a client with minimal latency. Maybe I also need to, just a moment. So real-time communication can be, let me abbreviate it as RTC, okay? RTC, real-time communication. And I can delete this and say it is the continuous, if you can type it correctly, continuous exchange of messages between client and the server with minimal latency. So minimal latency is the keyword here. And I'm going to walk you through the protocols that can help you to exchange messages continuously with minimal latency. In the previous section, we talked about REST, but in the REST standard, you have to first of all send a request. When you send a request, then the server must return a response, but all this happens only when a request is made. Imagine a situation whereby you have a server, okay? A server sending a response or sending a message or data to the front end or to the client without having the client requesting for that information. That is what real-time communication is all about, whereby a client receives a message from the server without asking for it, okay? And can receive it at any time. So let's talk about one way you can achieve real-time communication, which is polling. So with polling, this is how it works. Assuming you have a client. So I'll draw a client right here. You have a client, and this client sends requests to a particular server. Okay, server to request for a particular resource. Maybe the client wants to get the latest posts. Okay, the client can decide to message the server at a particular interval. Okay, I want you to have this in your mind. A particular interval, and this interval is defined in times of time. It could be something like maybe every 10 minutes. It could be maybe every, I don't know, 1 hour. The interval is determined according to the business need. So don't cram that in polling. You must have an interval of 10 minutes or 1 hour or 15 minutes or 1 second. Always do it according to the business needs or the functional requirements. Have this always at the back of your mind. The reason we design systems is to make sure that we have something that is scalable, efficient, and performant according to the functional and non-functional requirements. Now, when we have this interval and we have our client making requests to the server at particular intervals, this is what is called polling. So you might have maybe a REST API endpoint like maybe slash posts, okay? And the client requests for new posts every 10 minutes, every 10 minutes, every 10 minutes, every 10 minutes, or every an hour, or every 5 minutes, or every second. That is how you can kind of have RTC or real-time communication. This is polling in its very basic form or basic definition. Something else I can talk about is now WebSockets. Okay, just talk about WebSockets briefly. So I'll delete this and then edit this to WebSockets. In fact, before WebSockets, let me talk about long polling, since it's directly related to polling. So with long polling, this is what happens. The first step is that the client sends a request to the server. That is the first thing. The client sends a request to the server. Then the server holds that request. Okay, so the first step, the client sends the request to the server. Then the second step is that that server holds that request. And when there is new information, the server communicates and sends that response or that new message or new data back to the client. When the server sends this new data to the client immediately, at that very instance, the client immediately sends another request to the server. Okay, and the server again holds that request. Okay, and when new data is available, the server then responds. Okay, that is long polling. That's how it works. It's much better than polling, whereby you have to continuously send requests from the client side to the server. In this case, client only sends a request and the server holds that request. In the event that whatever the client wanted is ready, the server sends a response back. As simple as that. Then, as soon as the response reaches the client again sends the request immediately. Okay, so that later, if the server has the response ready, it gives the client. As simple as that. Now, let's go to WebSockets. And all these are things that I want to implement and teach you on this channel. Right now, I'm just giving you the bare minimum to give you a foundation to understand what these protocols are all about. Now, let's talk about WebSockets. So what is a WebSocket? A WebSocket is a persistent and full duplex communication over a single TCP connection between a client and a server. I have mentioned some keywords that I need you to take and put at the back of your mind. I've mentioned a number of keywords and I'll write them down here. Okay. The first one I said is that a WebSocket is a persistent. Okay. Persistent connection. It is full duplex. I'm going to explain this in a minute. And it occurs over a TCP connection, a single TCP connection. With a WebSocket, you don't have a client always requesting the server for data. Okay, the connection is always open. Once the connection has been established between the client and the server, it remains open. And this happens over a single TCP connection. I explained TCP in this playlist. Please check either this video or one of the videos before it. But actually, it should be in this video. Okay, sorry about that, because I'm talking about protocols. And every protocol I'm talking about is in this video. So it should be in the section before this. Now, when this happens, okay, I want to explain to you the entire process. How does it happen? The client sends a normal HTTP request to the server with an upgrade header. The client sends a normal HTTP request to the server with an upgrade header, telling the server to upgrade the connection to a WebSocket. The server then accepts, okay, and a connection is now established between the client and the server. Once this connection has been accepted and established, then messages can be sent and exchanged between the client and the server. And these messages are sent in what they call frames. Think of a frame as a chunk of message, of chunk of data. And anyone can send messages, okay? That's the meaning of full duplex. The server can send a message, the client can send a message, okay? Anyone can request for anything at any time. Messages can flow in any direction. There is no restriction. It could be server to the client, client to server, okay? Some people call it bi-directional. It is either way. For the connection to be terminated, either the client can terminate the connection or the server can terminate the connection. And it has minimal latency, the minimalist latency amongst what I've shared with you so far. WebSockets are very, very powerful and are known. Now, system design is all about trade-offs. Very soon I'll explain to you why WebSockets may not be the ideal thing that you need to use. And also I'll explain to you why it has its challenges. Okay, but I want to introduce that right now. When we go into advanced scenarios, when we are designing real-world systems, I'll explain some of these trade-offs. But sometimes you know that WebSockets cannot be supported. So if a WebSocket is not supported, then use long polling. Or sometimes if WebSocket is overkill, simply use polling or long polling. All right, now let's talk about another one called SSE. SSE is simply an abbreviation for the server sent events that I talked about earlier. So what is a server sent event? A server sent event is a push only kind of protocol. A push only. Okay, and I'll explain what I mean by push only. It occurs in such a way that the client cannot send messages to the server. There is no way that can happen with server sent events. Only servers send events or data to our clients, and this data is sent in form of events. Okay, in the browser, your client will have to implement what is called an event source object, and this event source object will be responsible for listening to new events from the server. So it is a push on. The server pushes events to the client. And of course, there can be like retry mechanisms, a little more that you need to know about SSE to implement it. On this channel, I have a playlist where I build a flight booking engine. And in that flight booking engine, I talked about server sent events in detail. If you're interested, please check out that playlist. You will like it. But also, as I continue teaching you system design, I'm going to touch on some of these concepts deeply in the coming videos. So for now, understand that a server sent event is a push only mechanism whereby the server pushes events or pushes messages as events to the client, and the client's work is only to listen to these events and does not push them back. In the project I mentioned, I implemented notifications using server sent events in a Fast API backend and a Next.js frontend. So check it out. You may not be disappointed. All right, this brings us to the end of protocols that deal with real-time communication. I'm going to talk about more modern protocols in the next section. See you over there. Hey everyone, let's talk about gRPC and GraphQL. These are modern things that take us beyond REST. So I'll start by talking about one at a time. So let's start with gRPC. I will drag this and maybe first of all duplicate it. Sorry, what am I doing? Copy, duplicate, drag this back and talk about gRPC first. Now, what is gRPC? I'll define it in full. I'll call it the Google Remote. I should use a different color for this. Let me pick maybe blue. The Google Remote Procedure Call. Okay, just a name, But what is it exactly? What would you define it as? If someone asks you what is gRPC, you wouldn't say it's Google Remote Procedure Call. You look crazy. When asked, define gRPC as a high performance framework used for communication between services, especially microservices. It is also open source. Okay. Let me write a few things here. Number one, gRPC is open source. These are key things to keep in mind. It's an open source, high performance framework built for efficient and good performant communication between microservices. So it is open source and it is built on HTTP 2. So REST is built on HTTP 1, but gRPC is based on HTTP 2 and what is called protocol buffers. So I'm going to go into explaining more. So based on HTTP 2 and also protocol buffers. Protocol, if I can spell this correctly, sorry, I want to make them aligned. I should have used the text box. I don't know why I always make my life more difficult. So protocol buffers. So what is a protocol buffer? It is simply a serialization format which was developed by Google. And in simple terms, it's simply a way that you can structure and send data efficiently between APIs. Okay, it is similar to JSON and XML in REST APIs, but this one is much, much faster. So what happens really with gRPC? Let's go step by step. The idea is this, okay? Actually, let me use a text box. It will be much easier for me to write. So I'll just drag this down. So what's the key idea about gRPC? So let's talk about the key idea around gRPC. So with gRPC, you first of all start by defining your data. What do I mean by this? You define the structure of your data. And defining your structure of the data happens in a particular file. Just like when you're writing Python, you use a .py file. When you're writing JavaScript, you use a .js file. With protobufs, you define your structure of your data, and it is called a proto file, a .proto file. Okay, proto file is where you use to define your data. I'll give an example. For example, if you were creating maybe a user, you'd say message, then curly braces. Actually, I need to create something new, a new text box for this. Sorry, copy, duplicate, drag this down and highlight everything and say message. I want to create a new, it will be like this, message. Okay, open and close curly braces. Then you see the message defines a user structure. Okay, and this user will have a name, okay, which is a string, as simple as that. And then you can have also an age, which is an integer, and you can specify the number of bits by saying it is a 32-bit integer. This is a rough way, okay, a rough way of how you can define a structure in a proto file. Actually, to make it look clear and accurate, you have to say something like equals to 1 full colon, then equals to 2 full colon. Now, this is not a tutorial about protobufs, but I want to just tell you about how you can define the structures for your data in a proto file. If you want to know how this works in a real application, I have a playlist on this channel where I introduce and build a microservice using FastAPI. And in one of the videos, I talk about protofiles. I create a protofile and implement it from scratch, and it's actually usable. So if you need it, please look at that playlist. I will leave a link in the description. Now, after you've defined your data structure, okay, I'll copy this, copy this. Okay, sorry, I need to copy the whole text box and duplicate it and drag it down. So when you're done defining your data structure, the next thing is to generate what they call client code and server code. Okay, and this, let me say generate code, and this code can be anything. Okay, it could be Python. Okay, it could be maybe Go, it could be Java. Okay, there are various languages that you can generate the code in. What matters is having your proto file that defines your data structure, like I've showed you this. A message, which is of type user, which will have a name and a 32-bit integer. And by the way, I don't think this is initialization. This is not initialization. Again, like I've said, if you want to learn this, check that playlist. Now, what else can I talk about gRPC? I'm trying to keep it basic without having to complicate it for you. Okay, but it's very, very, very important to know about gRPC in the modern world. If there's anything that you should take out from this, is that it is simply a high performance framework that you use for communication between microservices. It's built on HTTP2 and uses protocol buffers. Okay, I said HTTP2. I almost bit my tongue around there, but anyway, I'm sorry for that. Let's continue. I want to talk about maybe a few things about gRPC again. One of the reasons we have gRPC is because it gives us full duplex communication. Okay, so I'll copy this and type here, and I'll say key benefits. Key benefits. So understand this so that when we are implementing things, it's easy for you to comprehend. So what I want, some of the key benefits that we get when we are working with gRPC. Number one is that you have a full duplex, okay, system or full duplex communication. What am I typing? Did I say full direction? I guess I'm getting tired. So full duplex, or you can say bidirectional, meaning you can have communication from a server to a client or from a client to the server. It can be either way, not one way. Okay. And because of this, gRPC can help us with streaming of data or real time. I call it real time streaming of data. Very underrated, but very, very good. So what else comes to my mind? It has an advantage of compression. Okay. You have smaller chunks of data that are transferred between services during the API calls, because what you actually have is binary, what can I call them? You have binary pieces of data, okay, transferred between services. It's not like in REST where you have JSON or XML, okay? So that binary stuff is not human readable. That's the only disadvantage. But the advantage is that it is way faster and it is bidirectional or full duplex, and we can achieve real-time streaming with this, and we have better compression. And because of this, you can be used in things like multi-language systems. Like I've showed you, you can generate Python code, Go code, Java code, JavaScript code according to your protofiles. And also because of this, you can use it in microservices, streaming applications, even IoT applications. All right. I hope you understand what that is and everything I've talked about gRPC. Again, I'm trying to keep it very basic. If I've tried to complicate things, okay, please let me know in the comment section. I can make a follow-up video or explain to you in the comment section. All right, now I want to discuss GraphQL. Maybe before that, you may be asking, when is that one reason, or when is that one time I can use gRPC? Take this, okay, from this video. Use gRPC if you want fast, high-performance communication between your microservices. As simple as that. And I've implemented that in a project on this channel, in a playlist where I build microservices using FastAPI. And at some point, I had to do inter-service communication using gRPC. Okay, so I will move. I want to copy this again. Copy and duplicate. Wow, I did the wrong thing. Then drag it down so that I explain to you my thoughts on GraphQL. Okay, so we're done with gRPC. It's time for GraphQL. So what is GraphQL? GraphQL is also a flexible query language. Why did I say also? Like I've talked about one. I haven't talked about any other query language in this video, but just know that GraphQL is a flexible query language which operates over a single endpoint. I need to be typing these keywords. Okay. So you have your client C and you have your server C, which communicate over a single endpoint. Remember, in REST, you have multiple endpoints that you're using to access a number of resources. But in GraphQL, you have only and only one endpoint. Okay, so I'll say you have a single endpoint, It's the first key thing that you have in GraphQL. And this single endpoint is used for communication to a GraphQL server. Have that in your mind, to a GraphQL server. And because of this, GraphQL helps you to reduce API calls, okay? Reduced API calls. You simply have only one endpoint, okay, that you use for making requests to the server, not so many endpoints, okay? And with GraphQL, you can fetch only what you want. Fetch only what you need. For example, in REST, if you're working in a REST application and you wanted to maybe fetch user profile data, the user profile has maybe first name, last name, email, description, I don't know, next of kin, whatever. Okay, it could be probably around 20 fields for user profile. And what you need maybe for a simple mobile UI, 4 fields out of 20. In REST, you may either have to call another API endpoint to fetch only that data, or fetch everything and refilter it in the front end, or have another alternative that is to use GraphQL. With GraphQL, even if the backend supplies all that data, you can tell GraphQL, I only need the first name and last name, still using that single endpoint. Later, if you need 3, you can use that same endpoint for only fetching 3 endpoints. If you wanted all of them, you can still use the same endpoint for fetching all. Okay, so GraphQL is very good for front-end driven applications, and trust me, it can also help you with aggregation. Okay, aggregating so many API calls into one. So let me just type this down. So whenever you need things like aggregation, okay, of multiple, can I type? Guys, I keep forgetting spellings. How do you spell multiple? Okay, multiple APIs. When you need this, think about GraphQL fast. Also, by the way, something comes to my mind. When you have a scenario whereby you have slow network, okay, slow networks, GraphQL can help you a little bit, because think about this. If you have a slow network, you want to fetch as little data as possible. You need to fetch only necessary data. Fetch only what you need. This is where GraphQL comes in. So that in the event that maybe you can eliminate chunks of data and only fetch a small chunk, you make that query to the GraphQL server. Yeah, it's a very simple thing actually to implement, and you can learn about it. Like I said, I'm keeping it basic for now. And one thing I need to tell you is that in system design, we have trade-offs, okay? So with what I've explained to you about GraphQL, about protobufs, try to understand as much as possible, okay? And with what I've told you, you should be able to decide according to the business need whether to implement GraphQL, or to use things like REST, or to use gRPC. But don't worry, as we go into the next upcoming videos, I'm going to go deeper into these concepts. Okay, and at some point in the future, I plan to implement some of these things like GraphQL APIs, gRPCs, REST, and so on. Okay, of course, I already have gRPC and REST on this channel, but there's no GraphQL. But at some point, I would want to do this. Okay, but for now, I want to go deep into the system design, where we explain trade-offs between each of these protocols. In the next video, we're going to go deeper into system design. I want to go into scalability, where I'm going to now go into what they call the meat of system design. And if it is anything I would require of you, okay, when you're learning system design, is to start with scalability. So these first two videos were a foundation. So we're going to go into scalability, and from scalability, we're going to grow and go deeper and deeper into several things that are required for you to understand system design and to be a good designer of efficient, scalable, and maintainable and performant applications. See you soon.